Alright, so technically this is my third video, but this is really the second video that you should be watching on related rates. So your homework today is to watch this video and particularly follow along with practice number 2. That's kind of the tricky one. So remember that I'm going to be using your completion of this video as your homework grade this term. You just need to finish watching it, right? Even if you get all the questions wrong, that's fine. It's not fine, but I'm not going to take points off. So I've listed the steps here as a reminder for how to solve a related rates problem. I'm going to try to keep this video under 15 minutes. Whatever questions that you have afterwards, we will answer in class on Tuesday. And hopefully this will be helpful. So let's go on to question number 2. We're doing practice 2. Alright, so practice 2. A 13-foot ladder is leaning against the wall. If, at a certain instant, the bottom of the ladder is 2 feet from the wall and is being pushed toward the wall at a rate of 6 inches per second, how fast is the acute angle that the ladder makes with the ground increasing? So this is a new type of problem because we haven't done anything with, we haven't done anything with angles before. Now, when we're talking about angles, we are going to be using sine and cosine, and I have given you 2 derivatives that might be helpful in this problem. We might not use both of them, but they're both helpful to know. So, the information that I've given you, which is right over here, is that if you're given, for example, f of x equals sine of x, then the derivative of sine is cosine of x. And the derivative of cosine of x is negative sine of x. Right, so I know you guys haven't seen this before. That's totally fine. That's why I'm giving it to you here. So, as usual, our first step is to draw a picture. So let's do that. So the picture it's a ladder. Everybody loves ladders. So here is the wall. Here's the wall. Here's the ground. And what we have is the ladder. Now, we often talk about labeling things that don't change. The ladder is not going to change in length, so I can write 13 right here, right? But the other 2 numbers that we have, which are 2 and a rate of 6 inches, those are both numbers that are changing, right? Because they're pushing. This ladder is being pushed toward the wall, which means that this length is changing. So, since there are no other numbers that I can write on my picture, I'm going to label it with variables. So I'm going to say that the distance from the wall, bottom of the wall, to the bottom of the ladder, I'm going to say is x. And from the bottom of the wall to the top of the ladder, I'm going to say is y. And that's really going to help us when we write our given and find information. So, in this case, before I write the equation, I'm going to write down what I'm given and what I have to find, because the equation might not be so clear. So let me write my given. I'll have enough space. So, given. It says the bottom of the ladder is 2 feet from the wall. That's when I have to find it, and it's being pushed toward the wall at a rate, here we go, of 6 inches per second. So I know that what I want to find is dx over dt, which equals 6 inches per second. I don't know. Second. Okay. Now, the reason why I left such a big space after the equal sign is it's saying that the ladder is being pushed toward the wall. So is the x increasing or decreasing? right? So x is actually decreasing because this distance is getting smaller and smaller. So my dx over dt is actually going to be negative. Now, let's see if we can do what we have to find. So we have to find, what do we have to find? Let's see, how fast, okay, so I know it's something over dt because it's how fast. How fast is the acute angle? So we have to find how an angle is changing. So to label an angle, I'm going to use theta, and the theta is going to actually be right here. So what I want to know is how fast, I want to find d theta over dt when x equals 2. And we'll talk about the units for this in a little bit. Alright guys, sorry, I just need a little bit more space on my sheet. So, we're here, right? We want to find d theta over dt when x equals 2. And we know that we have this picture right here. So, the question is, what kind of equation can we write that has anything to do with theta? And hopefully you're looking at this FYI that I've given you and having some ideas. So, we know x, and we know 13. We want to find theta. Is there any equation that helps us relate, show the relationship between x and 13? That's right. So we actually don't even need to use the sine equation, but we are going to be using this cosine equation. We know that cosine theta equals x over 13. Right? Adjacent over hypotenuse. So let me just write that in a slightly different way before we take the derivative. I'm going to write cosine theta equals 1 over 13x, right? And then now I'm going to take the derivative with respect to t. So this is where this information becomes helpful. So I know that the derivative of cosine is negative sine. So I'm going to write negative sine theta. And because I'm still using a chain rule, I'm still going to multiply it by d theta over dt. And this equals, okay, well, the derivative of 1 over 13x is, of course, just 1 over 13. But I'm still going to need to multiply it by 1 over 13 times dx over dt. So I'm going to give you some time to fill in the information that you can and to think about how you might figure out sine theta as I get more space. Alright guys, so hopefully you've plugged in your number for dx over dt, which is negative 0.5. And now we're just looking for sine theta. Now there's a couple ways to do this. I'm going to show you the way that I think is the easiest. So if you remember our original equation, let me write that here actually. Our original equation was that cosine theta equals x over 13, right? So, so cosine is adjacent over hypotenuse. We know that sine is actually opposite over hypotenuse, which means that it's going to be y over 13. Now, is there any way, if we know that it's 13, hypotenuse is 13, and we know that right now anyway, x equals 2. So x equals 2. So when hypotenuse equals 13, x equals 2, what does y equal? So let's use our Pythagorean theorem. We know that 13 squared equals 2 squared plus y squared, right? And if you solve this, you are going to get that y equals the square root of, I have this written down somewhere, but now I can't find it. 169 of 165. So y is actually square root of 165. 5, which means that sine theta, that negative doesn't change, so that negative is still here, negative. Sine theta is going to be the square root of 165 over 13. So it's the opposite over hypotenuse. Okay, so once you plug this into the calculator, then the final answer that you should get is that d theta over dt equals 0.0389. So now we know that d theta over dt equals 0.0389. We didn't talk so much about units at the beginning of the problem, but I'll talk about them now. Now, if you didn't get this number, one common mistake might be that your calculator or your cell phone might not be in radians. So check that, and that's actually going to be our units for this problem. So 0.0389 radians. I'm going to write RAD to represent radians, and it's per second. Okay, so my final answer is the angle is increasing at 0.0389 radians per second. And we are all set. All right, bye.